coming down, we stopped here so you could actually have an end view of this thing and actually get a look at the steps and the balconies from this side. And what we were talking about earlier at the other building, how the standpipe is connected to the fire escape. So you're actually looking at an additional weight and loading issue that's coming up on that one. But this is a great place as you're walking up to it or driving by it, which unfortunately I've had the opportunity to pick up several driving by. If you see something not right, it's probably time to stop and take a closer look, because the broken things will be there. They're not going to look right just at a glance.
Some drop-ins coming down.
Counterbalance. Okay. Is that something that is immediate concern, or is it something
that is a higher level concern than an extension cord in the office? We would want to correct that in the next 10 days. Should have never got that right.
Yeah, I know. We're going to talk about that. So let's take one piece at a time. This standpipe is attached to the structure, and it's not independent of the structure. The engineer needs to deal with that. Like you said, when it's full of water, it's a whole different animal. So does it look like the brackets were done any differently than the other brackets to support this extra weight? Otherwise, the engineers may want to have this thing bracket off, keep it still attached, but give it another re-support to the building so that this is independent, right? Now look at that corner right up there. You see any rust growing on that angle? Yeah. Can that be load tested as we speak? Now let's look up original hardware and or evidence of any maintenance. Straight up and look at any evidence of maintenance. So we got all the treads comes up the top. So all the treads got rivets, right? So 50 to 75-year-old rivets on every tread.
Put some new screen over there.
Look at all the railings. All the railings have original square heads holding up every piece of railing. It's been painted. Look at the stair. Look at the ladder. Platform. Look where it's rusted through right there. Yeah, and it's rusted through at the bottom. Let's take a look at the ladder that the firemen are going to use. Any lap joint. Remember, guys, rust jacking. Any rust jacking on the staircase made specifically for the firemen. Right?
Outside right joint.
Yeah, outside right joint. You can see that. And plus, on the entire ladder, original hardware or new hardware on the ladder.
That's original.
All original hardware. On the supports holding up this entire platform, original or reinforced? All original. Tying back into the building, any rusty tiers coming from the building?
Oh yeah.
Can you see? I mean, they painted this building very nicely. Anybody see any rusty tiers?
This first window right here, just to the left. Just to the left.
Yep, you can see that it's been giving. Okay, what's going on with this?
This other one, just to the right.
What's going on with this cage here? What does this look like?
They got rid of the swing ladder.
They got rid of their cantilever. So there used to be a cantilever here. So what do they need now in order to get to the ground? If you're an engineer and you're signing off on this, is it a complete or incomplete system? And who's going to resolve that issue? You or the fire marshal? You just need to note it that it's an incomplete system. So I would put a ladder, and I would make room on either side. A fold-out ladder would come down this way. It would come all the way down here and perfectly fix one leg to the ground, and it looks like a drain pipe right here, and then it flops out. And it's an 18-inch flop-out ladder. Yeah. So that's how you're going to get some of these cantilevers that were gone. Now he knows, because if this wasn't done with a permit and an appeal, guess what you're going to put back here? And cantilever. If it's been appealed correctly, you put back a ladder. That's the answer. It needs a ladder, and that's what your engineer's right. She's right. It needs a ladder to the ground. Oh, I took the cantilever away. Yeah, but you're now locking up a bunch of people on the 14 feet off the ground. What are they going to do? Jump or wait for the fire department? It's an incomplete system, that's all. And then let them deal with it. They're going to deal with the owner because will the engineers sign off on this if it's an incomplete system without a huge disclaimer? So it's been painted, right? Let's take a look at the treads. Any run from any of the treads that anybody can see.
Oh yeah.
If you look up the treads and see what's called rusty eyeliner, which basically is a black line of rust.
Yeah.
And you've got rivets and you got some squares when you look straight up. Anybody see one hex head bolt on this thing?
Yep.
One. No. Anybody see a refurbishment? Does anybody see one refurbishment on this fire escape? Anywhere? Do you see any hex head bolt that was an indication that somewhere, sometime, in 25 to 50 years, somebody changed one bolt on this?
What I see is what you're asking. This first step, the rivets are out, and they may have welded that.
Yeah. I'm trying to show you that when you look up at a fire escape, are you looking at 90 to 100% of original hardware, or is there any change, any evidence of maintenance in its 50 to 75 year life? Do you see any here? 90 to 100. Oh, this one? It would be a hex head, it would be shiny new, and so with that, would you allow, okay guys, now with that, knowing what you know, there's no evidence of maintenance, all original squares and rivets, will you allow a load test? Do you think the city will allow a live load test without any refurbishment to this prior to a load test? But it's happening. So be careful. There's some load testing going on the as-is condition, because the load test was $5 grand or 10 grand. Even though it may need 10, 20 grand worth of refurbishment, some load tests are getting forced because some load tests are getting forced because the owner starts freaking out to the city that I got a $5,000 load test but a $25,000 refurbishment. What you got to do as an engineer is step in and say, I want to allow a load test in the as-is because the failure is catastrophic. And if I was going to load test this thing, I want let's assume that every one of these connections on the tread, every support, every railing, I've identified through my engineer that the connection is good to excellent. I just back it up with a bolt, then I can load test it. Because the only reason why you're doing the reinforcement is because the bolt is old. It's, on this case, it's 75 to 100 years old.
Well, what do you do in the case of this, like where you've got this rivet at the other side of the platform? You can't just put in a new bolt. You're going to have to either draw the rivets or you have to reinforce it some other way. One is more expensive to replace those connections.
Guys, yeah, you brought up a good point on the grading. Here's the answer on the grading. The grading runs in a certain way that the rivets, there's a strap that's the main support of your grading. There's straps that run the other way that are not part of the support.
Guys, step off the street. My friends with the TriMet are very rude.
So you only reinforce the major structural connections, not the minor. So on grading, there's major structural that must be rebolted, but there's minor structural that all you do is verify that it's in good condition. You don't need to change out those. You're going to change the major structural, not the minor structural on the railing. Only the major structural on the railing.
They've got bolts on the underside of the platform, and then they come up the main bar, and there's only one rivet at the end of it.
But it's overlapping. That one is overlapping. The only one you change is the outside one. The inside ones, if they're in good excellent condition, they stay. That's the minor one.
Right,
they're resting on top.
There's no room to, unless you drill out the rivet, you can't fit
on the outside. On the outside one, only the outside one, not the inside one.
Right, there's no room.
Yeah. Cut the head. A lot of times when you grab a grinder, you cut the head of a rivet, and you just pile it through and put up another bolt. You're done. All right, let's take a look. Pass or fail? Fail. Address?
34 Northwest.
34 Northwest. Now, you're going to get the certificate already on this. We're just revisiting it. Even if you get a load test today, can you write a new violation tomorrow on the same structure?
And that's one of the caveats we've got right now on the part where our guys are giving them 5 years from now to get the engineering test done and the evaluation repairs. We gave you 5 years, but if I happen to come back next year and look at it and it's gone that way,
there you go.
Maybe a new call.
And this one is 75 to 100 years old. When is the load test required?
About 25 years ago.
Now, if it was 25 to 50 years old, when do you want the load test? Within 5 year period?
5 years.
Okay, so if it's 75 to 100, is that a safe number? But the 50 to 75 is on a case-by-case basis. You'll decide whether you will enforce it now or whether you're going to give them the 5 year based on the condition. And if you got somebody that never takes care of their fire escape on a 50 to 75 years, you would initiate the immediate load test. If you've got somebody that's constantly painting it, you know what I'm saying, like this is one of those buildings I think that's constantly been painted. So, but they're still 75 to 100 years old, so they're gonna get forced into a load test. And you got rust eating through, so that's another indicator that you've got things here that were probably not caught by the previous engineer. So it's a questionable look back at this fire escape. Because I don't know if you call it a different kind of violation, but you basically want to revisit this address. 34 Northwest.